continuation from last class, just day 6. We're doing more on graphing, right? More stuff on polynomials. So, important features, the domain is the x values, right? Always all real numbers. Okay, so for your range is, of course, talking about the y values, right? From the bottom to the top. If it's an odd function, and by that I mean x to the third, x to the fifth, or just x, right? Because that's x to the first power, right? Odd functions, the range is always all real numbers. All right? Because you have an arrow going down and up, or up and down, okay? For your even functions, so x squared, x to the fourth, x to the sixth, and so on, look at your lowest min or your highest max, because that's where it will start or stop, okay? All right, continuous, as always, yes. All right, and one-to-one. Which line test do we use to determine if it's horizontal line test? Good. Horizontal line test. Does it hit the graph in only one spot? If you say yes, okay, good. It's one-to-one. If you say no, then no, it's not one-to-one. Okay?
So it's both answers are possible.
Oh, for one-to-one? All right, so your intercepts, your y-intercept is A in standard form. 8 to, okay, so your y-intercept, if your polynomial is written in standard form, okay, so from the highest exponent and on down, right, then your y-intercept is always your constant number, okay, so constant. So the number that's all the way down at the end with no x or y or whatever with it. Does that make sense? Okay. Does that make sense? Okay. All right, good. Okay, so let's look at the zeros of the x-intercepts. All right, so the number of zeros or the x-intercepts that you have is equal to your degree or your biggest exponent. All right? And we can find the zeros, as long as they're real zeros, you can find it in the calculator using Blinking Bob, second trace zero. Or you may have imaginary zeros, and then that means you have to actually solve using the quadratic formula, using whatever, okay? Square root method, hating the square. All right, so now let's look at local maximum. So local maximum, first of all, do we remember what a maximum and a minimum are? Yes? Okay. Maximum up, minimum down, right? So the local maximum is basically where the function switches from increasing to decreasing. Does that make sense? Because your maximum looks like this. So it goes from increasing to decreasing. Right? And that makes sense, right? So the local minimum, which would look like this, is where it switches from decreasing to what? Increasing, yeah. Okay? Your increasing and decreasing intervals are separated by these local minimums and local maximums, all right? When we looked at quadratics, there was only one maximum or one minimum. But now that we have a bunch of terms, you can have, you can have more than, you can have like 2 maximums and 1 minimum. You could have 2 minimums and 1 maximum. You see what I'm saying? So increasing is where the slope is, positive. Not going up. Say positive. What it says on the key. So decreasing is where the slope is negative because it's going down. Yeah. What it slope is positive because it's going up. Negative because it's going down. Okay? And the end behavior is basically what we said when we were going over the homework, right? Even functions, even number degrees, right? They have the same end behavior. So right arm goes up, left arm goes up. Right one goes down, left one goes down. Okay? Odd, they do opposites. Okay? Alright. So good for that one. Any questions about this? Okay. So let's take a look at, just kind of tying everything all together to a function, okay? So if I have x plus 4, what is that? Is that cube? Minus 1. All right, this is written in vertex form, right? We can talk about the transformations here. So what does this negative 1 do at the end? Good. Down 1. What does this plus 4 inside the parentheses do? Left 4. Good. Do I have anything else? Any other transformations? No. What do we say the domain is always? Okay. Hold on. Is this an even function or an odd function? Odd. So what do we know about the range for odd? Yeah, all real numbers. And and that we could graph it first, and then I'll talk about it, because we can actually see the graph. But that's also something very helpful to just kind of remember, right? Odd. Okay, so let's graph this. All right? Put it into your calculator. Go get your points. Go to your table. Let's graph it. All right. All right. So I realized down here, 1, 2, 3, 4, 5, 6, negative 6 goes off, right? Just eyeball it. That's okay.
What if on excess, like, it goes off the graph? Would you draw a point off of the graph?
Yeah. I mean, we try to make it so that the test isn't as messy. But if it does, you can just eyeball it. Make it neat. Okay. Okay, so this is what my graph looks like. All right. Where's my 0? -3. -3, 0. And this is not a times 3, 0 because it didn't happen right here. Right? There's just 1 0 there. Okay, so. But this is a cubic function. Where are my 2 other solutions? If they're not real. If I only have 1 real. Yes, Yul. One real.
This one is triple.
Is it? Did I do?
Whenever the factor polynomial can be represented in the vertex form.
If it's in vertex form. Oh my god, I didn't even know that. Okay. Oh my god. Thank you. So, sorry. Let me take it back. Okay. So, did you guys hear what Ms. R said? It's in vertex form, right? So you know what? This is a times 3. All right. So if you solve this out, you would get the times 3, which yes. All right. Times 3. Sorry. All right. So what is my y-intercept? We'll do this, and I'll let you guys go to lunch. Yeah, just so you know that it is the times 3 there. Okay, so the y-intercept. If you already have this on your calculator, can somebody do this for me really quickly?
0.63.
Oh, it's a 0.63. Go to trace 0, enter.
It is 0.
Okay, thank you. All right, you guys really want to go to lunch? See? Okay, so is this graph continuous? What do we say? Yes.
Always.
All right, now, is this 1-to-1? Yeah? Good, it is. It is 1-to-1. If I draw a horizontal line and I run it through this graph, it only hits it at one spot. Okay, so local maximum and the local minimum. All right. So this one is for both of them. It doesn't have a local max or a local min. Okay, there isn't like a increase and a decrease and decrease and increase. There's none of that. Okay. This one is gonna be like the cube. The cubic functions are, it's either increasing the whole way or it's decreasing the whole way. Okay. So with this graph, if you look at this one, starting from the left to the right, what is this one doing? It's increasing the whole way, all right? And you can tell because your right arm is going up. From the left to the right, if the right one's going up, increasing. All right, so then this one is increasing all the way from negative infinity to infinity. All right? So then is this decreasing anywhere? No. Okay? All right, so now we're going to look at the n behaviors. All right, that's the arms of the graph. So left n behavior is this, as x approaches negative infinity, right? That's the left arm. What is this left arm doing? Up, down, straight, down. Yeah. So it's going down to negative infinity. Okay? So then the right end behavior, which looks like as x approaches infinity, what is the right end behavior doing? Uh-oh. Okay. This one is the one that I want. Okay. Right end behavior, where are we going? Up to infinity. Yep. Which they should. This is an x to the third power. They should be doing opposites. All right? Okay. So let's try the next one. All right, so this one, they gave us the graph. All right, guys, domain. What is the domain for this? Yeah, negative infinity to infinity. All real numbers. Now, let's talk about the range. From the bottom to the top. Well, the bottom, where are those two arrows going? Negative infinity. So you're coming up from negative infinity, and the graph stops where? At 0. Okay? 2 is here, 4 is here. This is 0. Okay? So from negative infinity to 0 with a bracket. Because there's an actual, closed point there. So now let's talk about local maximum and local minimum. Okay? Do you see a maximum here or maximums? I mean, you should. It's right there, right? Isn't this a maximum? And there's a maximum right there, right? So we have 2 at 2, 0, and 4, 0, right? So local maximums, and remember, these are points. So you want to give us, yes, 2, 0, and 4, 0. Okay? And what about a minimum? Is there a minimum, a local minimum? Yeah, right there. Okay, so be careful right there. What point is that at? 3, negative 1. So increasing intervals and decreasing intervals, right? So we said that the intervals happen from these local maximums and minimums, right? So what you can do, just do the same thing that we've been doing before. Draw a line where it changes direction, okay? So right through that local max. Another one right through that local min. Another one right through the other local max. Okay? Let's get the x numbers. So since you have an arrow on the left, that means we're coming from negative infinity, right? What is this?
Negative infinity with
Zero.
Okay, so that's 2, the x number, right? When the number doesn't go through on the x-axis. The next one is 3. Next one is 4. And then you have an arrow on the right. Where's that going? Mm-hmm. So what is this graph doing from negative infinity to 2? Increasing. Good. What is it doing from 2 to 3?
decreasing,
Uh-huh. And then from 3 to 4?
increasing,
And then from 4 to infinity?
decreasing.
Good. So our increasing intervals, we just have to go write it. Remember, you have to use parentheses. There are no brackets here. And how do you join these intervals? Not a comma. Somebody said it. A little u. Okay. So increasing is from negative infinity to 2. U 3 to 4. Decreasing is from 2 to 3. Okay. Questions about this? I'll just scroll up a little bit because there are people in the back. Oh. Okay, so real zeros. All right. So you know what? I know you guys have it written down. I'm going to erase all of this. Okay, just so I can show you where the zeros are. Where are my zeros? Yeah, right there. Right? Right there where the graph bounces off of the x-axis. It doesn't go through. Well, so yeah, they're both at the local maximums for this one. Not always. Not always. So your real zeros are at 2, 0, and at 4, 0, right?
Yes.
But it bounces off. So what does that tell me? How many do I have at 2? 2.
Double root.
How many do I have at 4? 2, right? So these are times 2s.
How do you indicate a double root? Like, do you have to? Or
I mean, you can just put DR.
do you have, I'm saying like on a test, if you know
Yes.
double root, how would you indicate it?
I mean, you could put DR
You
for
just
double
write it
root.
out twice?
Yeah. Or you could write it out twice. Sure. Yeah. Okay, so for these real zeros, you know what? I'm going to put it in a solution set. Okay. So Isaiah asked a good question. How do you indicate on a test or quiz that there are 2 or 3 of them? Okay. Well, you could write them all out, or you could say 2, and then I'm going to put times 2, so that I know that there's a multiplicity of 2 there. All right. And then I'm going to put 4. Now I'll put times 2. Okay. Or you could write them out as the x-intercepts and put times 2. You could put double root, dr, write them all out. Mrs. R, do you have another preference? Any other options? I mean, listen, that's, as long as you tell us that you know that there are doubles there, it's fine. Okay? But if you just put 2 comma 4, taking points off.
So it's going to be wrong. If you
Yeah.
indicate
Yeah, times 2. All right, so the reason why I'm saying you have to put that multiplicity is because, look at this. If you have two zeros at 2, that means you have 1, 2. If you have 2 zeros at 4, it means you have 3, 4, right?
So the 4 that corresponds to
Yeah, that's how many you should have, right? Because your degree is 4. So if I have all of my 4 real zeros here, then how many imaginary zeros do I have in this? 0. There are none. Okay? So now tell me about the left and right end behaviors. Left end behavior, where's it going? Negative infinity. And what about the right end behavior?
negative infinity and 12.
Good. Good. Same thing because it's an even function, or you can look at the graph and they're both going down, right? Okay, any questions about this? All right, so I'm going to skip this one because I'm going to get to the other things that we have to cover today. Let's go to finding the equations of polynomial functions. All right? All right, so now you guys can write out the equations to polynomial functions, okay? So if we give you a graph, this is how you should do it. First off, you want to find the zeros. Okay, so let's say the x-intercepts. That's easier to kind of remember since we have the graph. Okay? First thing you want to do is find the x-intercepts of the function. Where does it cross through or bounce off of the x-axis? And in all caps, if a graph turns at the x-axis, like it turns and bounces off, then this root is a repeated solution and you have to write it twice. Okay? Then you want to change each x-intercept into a factor. All right? And this is very similar to what we did before in a previous lesson. If my x-intercept is, say, at 2, 0, right? Then I know that this is, I can think of that as x equals 2. That's my 0, right? Turning that into a factor, well, then that means, so I'm going to do this. Say that's the 0. And then if I minus the 2, then I get x minus 2, and that's a factor. Does that make sense? Okay. If you take your 0 and you make it equal to 0, right, then you can get the factor. And you can kind of think of it as the opposite, too. If you have x equals a positive 2, then x minus 2 is your factor. Okay? And if x equals negative 2, then your factor would be x plus 2. All right? Huh? Yeah? All right, so then write the equation of the graph, and we'll take it in factored form. You don't even have to FOIL it out. Just give it to us in factored form. The last thing you do need to check, all right? You need to check whether your leading coefficient, so way in the beginning, your A, you need to check if your leading coefficient needs to be positive or negative, all right? And that is basically negative if your right arm is going down. All right? So I kind of abbreviated there as a shorthand. So it's negative. You need a negative in the front if your right arm, the right arm of the graph, is going down. Okay? All right, so let's take a look at these two. All right, so this one. Okay, first of all, wait, so this is what I'm going to do. Let's go and get our x-intercepts. Looks like it's right here, yeah? Okay, so I'm going to tell myself, okay, x equals negative 4. But it bounces off. So this is a times 2 situation, so you know what? X equals negative 4. I'm going to write it twice, okay? Now, the next thing I'm going to check is the right, what is the right arm doing? Right arm is going down. Uh-oh, then it's a negative. Okay? I'm going to lay it all out, and I'm going to put it all together. Okay? So, since x equals negative 4, well, if I take that guy and I make it equal to 0, then that means I need to add the 4, right? Then I get x plus 4 equals 0.
You do that twice, though.
Yeah, but I'm only going to do it once here because it's, you know, so
Yeah.
that's my factor. Okay, that's my factor. So my equation is y equals x plus 4, you can put squared here, or you could write it out twice. And don't forget, we said it's a negative because the right arm is going down. Does that make sense?
If the right arm goes down, it's negative.
Yes.
Why the right arm?
Because this is affected by your leading coefficient. Like if it was
So
positive,
that's the indicator.
Mhm.
Left one.
am I not the left one? No, I don't know. Sorry, do you know? Do you know? Do you know why the right arm is affected by the leading coefficient being, negative, or why not the left one?
Yes, just when you think about x squared,
This is.
like x is about a 4 plus x is about a 3 minus something, right? And you get really, really big number with an x. But first, it was like huge number to the power of 4, becomes significantly large. Whatever you do in the other terms, it's smaller, plus or minus significantly. I don't know.
Are you listening? You just asked.
Yeah.
Yeah? Well, and the thing is, guys, you can try it out.
Yeah, you can always try. When you're not sure and you forget, and you have something like this, right? Your heart action.
Let's look at the next one, okay? This one. First thing we should do is get what? X-intercepts. Okay, there we go. There's one at x equals what? And the next one is at? And the next one is at? Yep. Oh, and we should make sure that we found all of our zeros, because if I look at the first one, the turn, there's only one turn. One more than that, this should be a square, right? So I should have 2 x-intercepts. This one I have 3. My turns, I only have 2 turns, so this is all the x-intercepts that I need, right? Okay. So if I look at my right arm, this is going up, so this just stays positive. I don't have to worry about putting a negative in front of this one, right? So let's turn these x-intercepts into factors. So x equals -2. I'm gonna move, oh no. Oh no. Okay. Let me move this guy. Oh no. Hold on. Hold on. I know. What is happening? Wait a second. You know what? It needs to get locked. There we go. Okay. Alright, so move this over. Okay. So then this one, x equals -2. What is my factor? Alright, x plus 2. What is my factor for x equals 1? And for x equals 6?
X minus 6.
Good. Now, just write the equation in factored form. Make sure you put y equals, because you have to have an equal sign. This is an equation. And it doesn't matter what order I put these parentheses in, or these factors. No, it doesn't matter. Just make sure you don't mess up the signs, okay? Especially when you go back and you rewrite it, right? That happens to some people. Both of them. You know what? You should be able to do both of these. Let's try both of these, okay? Be careful of ones where you have, times 2. So
Must be like all of our problems.
that would be nice, wouldn't it? All right. So guys, tell me if I'm doing this right, okay? Yeah? If you wrote x minus 1 and then you put x minus 1 again, that's fine, okay? Or you could put square with the 1 that has a multiplicity of 2, okay? It does not have to be in this order, all right? Good. You should get this right. That Jawan. All right. So the next one too. Okay, so we have x equals -4, -2, x equals 1. None of these are times 2, times 3, nothing, right? However, right arm is going down, that's a negative, yeah? So y equals negative. Yes? Okay, good. Cooper, you good? All right, perfect. Okay, so let's get to the fun stuff. The fun stuff. Hey, you know what though? You know the stuff that we did last time with the graphing and synthetic and then solving? I usually think that's a pretty hard lesson, but you guys killed it. You did really well on the quiz, so good. This should be nothing. We're good. All right. So here's the thing now, right? You guys have to tell us the equation of a function if we just give you the zeros. Okay, so now it's going to change because we could give you non-real zeros. All right? So here's the thing. This is what you're going to do. Find any missing zeros. Okay? You're going to find any missing zeros of the function. Okay? So imaginary and square root. They come in groups of 2, so they have pairs, all right? Because we have because we have a conjugate.
What does conjugate mean?
Okay, so we'll talk about that when we get to that. Sometimes let me keep it. You know what? All right. And then what we're gonna do is we're gonna change each zero into a factor. Basically what we did just now, right? And the last part, you can't just leave it in factored form with these. We're going to have to multiply the zeros in order to write our equation in standard form. Okay? All right, so let's try this. All right, so example A. They gave us these zeros, 6, -3, and 5. Do you see any i's? Do you see any square roots? Okay, so we're...
How do you tell if there's going to be a negative in front if they just give you the zeros? Because you don't have a...
Oh, okay.
zero going down.
That's a good question. So we're going to assume that all of these are a is greater than 1. Okay?
So how do you tell if it's not, if the negative isn't in front of the factors? You know how like here, if the arrow is going to the negative infinity or whatever, it'll be a negative in front. How would you ascertain as to whether there's a negative?
You couldn't with just this. You don't have enough information.
Okay, so
they have to give you more
So
information.
they'll always be positive.
Yes, they're always positive. Mm-hmm.
I think the notes you need to sentence above it says stability coefficient of 1.
Oh, it doesn't say it there? We just don't have it up here?
I know.
Oh, okay. So all of these, if we give you just the zeros, leading coefficient is positive, okay? All right, so we don't see an I, we don't see a square root, so these are my zeros. Now, let's turn them into factors. X minus 6, x plus 3, x minus 5. Okay, so we're not missing any, zeros. That's what we have to work with. You know what? Then now, just multiply. Take 2 and double distribute. So we have x minus 6 times x plus 3. X multiplied to x plus 3. What's x times x? Squared. What's x times 3? Okay. And then now double distribute. Take the -6 and multiply it to everything, right? What's negative 6 times x? And what's negative 6 times 3? Negative 18? Yeah? And if you do it like this, then the 2 in the middle, you can combine. They're like terms, yeah? So you have x squared minus 3x minus 18, yeah?
So you just FOIL or wait, no?
Yeah, you're just FOILing, but now you have to take this trinomial and you have to multiply it with your other factor, x minus 5. Okay? How many of you guys have triple distributed? So fun. Look,
Oh, wait, so
I'll show you.
you multiply the first two, and then you just, the third one, you just...
We do it after you turn it into a trinomial. So I always start with the smaller one and I just distribute it to the bigger one. Okay? Smaller meaning to like a binomial and then distribute it to a trinomial. So x times x squared gives me x cubed. What is x times negative 3x? Yeah, negative 3x squared. What's x times negative 18? Negative 18x. Okay, and I'm going to show you a way here to kind of organize your work a little bit, all right? Now you got to take this negative 5 and distribute it to everyone, right? What is negative 5 times x squared? Negative 5x squared. What's negative 5 times negative 3x? Negative or positive? Positive 15x. And what's negative 5 times negative 18? Positive what?
90.
90. Negative times negative gives you positive, yeah?
Negative 5 times 15.
Times negative 18.
Oh.
So, the reason why I wrote it like this as I was multiplying, I mean, you can see why, right? You got to combine like terms, guys. We just add them. And then now, if I set myself up like this, well, then I can just, I have all my like terms just kind of lined up. I can just add straight down, all right? So then I have x cubed minus 8x squared minus 3x plus 90. So y equals that. There you go. Done. Yeah. Any questions about this? Are we okay with this? Okay, good. All right. So, B. Hold on, guys. Too much talking. Let's get it. All right. 2 and 1. Oh, 2, comma, and 1 is a double root, right? All right, so what does this tell me? I have 2, 1, and 1. It's a double root, yeah? So now let me go get my factors. X minus 2, x minus 1, x minus 1. When I do this, I'm not going to put the square because I have to multiply it all, right? So why not, let's just write it out and we can multiply, okay? So let's double distribute. And with these, you know, it doesn't really matter which order you choose, but I'm going to go with the ones first. I don't know, just because. I'm going to do x times, x minus 1 times x minus 1. Yeah? It's hard to write this way. Okay. Double distribute, x squared minus x. Double distribute, minus x plus 1. Be careful. Negative 1 times negative 1 is a positive 1. Okay? Too often we see, you know, students writing negative 1 there. Combine those. X squared minus 2x plus 1. Do you agree? I'm going too fast. Okay, I'll slow it down. So I multiplied that and I multiplied that one together. What do I still need to multiply to this trinomial now? X minus 2, okay? So then, yeah, right in front, x minus 2. Now let's triple distribute. Yeah. X times x squared gives me x cubed. X times negative 2x, negative 2x squared. X times 1 is, I mean, you can write 1x, it's just x, right? Since we're adding everything up, we can put 1x for now, right? And then this negative 2 needs to go to everybody. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is plus 4x. And negative 2 times a positive 1 is, there we go. Okay? Then I need to add. Basically, we're combining like terms, right? X cubed. What is this? And the next one? Okay, and then? Good. And there you go. Y equals. That is your equation. See, I told you it was fun. The best part isn't even, we didn't even get to that part yet. Huh? Oh yeah, the eyes. Well, the eyes mess it up a little bit, okay? So I need you guys to be like 200% when we do the eyes. Me too. 200%. All right. So, we ready? Okay, so what we said in the beginning, we said eyes and square roots come in pairs, right? So with this one, okay, they gave us I and they gave us 3. We're missing a 0 because the I needs to have its conjugate. And the conjugate is, well, we talked about this in the previous unit lessons. The conjugate just changes the sign of your imaginary number, okay? So right here, what is the sign on this imaginary? It's a positive, right? So the conjugate of that would be negative I, okay? So it's like they come together. They have to go together.
It would be x minus I.
Okay, all right.
Oh, it's the question.
Yeah, no, it is for that other one.
Okay.
But this one would be x
Maybe
plus
x
I.
plus I.
All right, so that one is the missing one. So we have 3 here, right? Okay, yeah.
Why are you changing it to more percentage?
No, I'm not changing it. I'm adding it on because that's the one that's missing. Conjugates. So, okay. All right. So before, when we first started talking about imaginary numbers and we started talking about complex numbers, 2 plus 3i. Yeah? That's a complex number because it has a real part and an imaginary. Yes? The complex conjugate for this is 2 minus 3i. Okay? They have to go together. So if I gave you 5i, yeah? Then the complex conjugate would be negative 5i.
Why do you have to have a conjugate?
Because with the imaginary, so with the imaginary numbers, right? You know, when we solve out imaginary numbers, right? You get, because there's a plus or minus
Plus
there.
minus is that lot?
Yeah, and if you were to turn this back, okay, so when we multiply this, see if it clicks, okay? Because some of you guys may be able to see it. It'll tie in to like all the factoring and things that you've been doing, all right? All right, so are we okay on the complex conjugate? Okay, all right. So then let's turn these guys into factors, okay? So if I have x equals I, and I have x equals negative I, and I have x equals 3, okay, which I do have. Let's turn these into factors. I know it's really easy with the numbers because we know, all right, minus the 3, so x minus 3 is the factor here. Yeah? just make sure that you're careful when you have complex numbers, okay? Here, you have to add the I. So your factor for this one is x plus I. Does that make sense? Yeah? And then this one, you would have to subtract the I, so it's x minus I. Okay? So those are the three factors that we're working with. Okay? Here's something else that you need to know. So Jaden, don't miss this, right? If you go to double distribute and multiply, right? You have to multiply your conjugates together. Like there's no switching up here. You can't multiply these two together. No.
Oh, so if you have conjugates, you have to multiply them.
You have to multiply the conjugates together. So these guys have to be multiplied together, and then you can multiply with the other ones. So let's multiply those. X minus I times x plus I know, so weird. Where are the numbers? Well, it doesn't matter. Right? We could have x squared plus ix. Distribute these guys down here. What's negative I times x?
Negative IX.
Negative ix. And what's negative I times I?
Negative I to the second.
Yeah. Negative I squared. They should always cancel out. Yes. You know what happens when you multiply is your i's should go away. Okay? If your i's do not go away, you miss something. This ix minus ix, that goes away. And this I squared, who remembers, what is I squared? What kind of one?
Negative 1.
Negative 1. So we have x squared minus negative 1.
So I squared is always negative 1.
Yeah.
Alright.
Can you change it to I squared plus 1?
Absolutely. It is x squared plus 1. And then look at this. You know, this is the factor. If we said find the zeros of this and you factored it out, then you would get plus or minus I. That's what we did. We just went backwards. Okay? Yeah.
Wait, so are we saying that negative I squared is 1? Or negative?
Negative 1.
On the calculator.
No. So I squared is negative 1. So a minus minus gives you a positive. Because you already had a negative here, and this guy is negative 1, so you have a minus minus. So that turned into a plus. Okay? All right, so now we did this and we did that. Now we have to combine or multiply this with x minus 3. So I'll do that up here. X squared plus 1 times x minus 3. Are we okay so far? All right, Leah, you good? All right. X squared times x gives me x cubed. X squared times negative 3.
It's 3x squared.
And then distribute these guys. What is this? Plus x minus 3. Well, there you go. Nothing to combine there, right?
Just make it final.
Yeah, that's your final answer. That is the equation.
Too bad.
It's not. It's really not bad. You guys are smart. You can do this. I don't know why you're laughing. Nobody else is laughing. If you're laughing, that's on you. So then, if you laugh, you're not included. All right. So let's look at the letter D. Let's look at this one. So it gets a little bit. I want to say it gets very important, bless you, to be neat when you have 2 plus 3i, things like that. Okay? It's going to get a little crazy. All right. So we have x equals 0. This is a complex number. I see an I. What is it missing? Okay, so what is its conjugate?
Negative 3I.
2 minus 3i. Okay. Don't forget the 2. 2 minus 3i. It only changes the sign of the imaginary part, not the real.
For x equals 0, what would you put? Would you put x plus 0 or
Oh,
x
for the
minus
factor? Yeah, okay.
0? Or is it both?
Thoroughly.
So remember when we turn these guys into factors, we make them equal to 0, right? So then, there you go. This one's already equal to 0. That's your factor. So that's,
So that's an answer. That's going to be part of your answer at the end.
this is a part of what you're multiplying.
So it's
If your x equals 0, then your factor is just x. Because when I switch these guys into factors, I try to make it equal 0. But this one's already equal to 0, so that's your factor, x. Okay?
Oh.
Alright.
Okay.
So this one, okay, so remember this is in parentheses. When you have terms joined together by a plus or minus, you can't just separate them willy-nilly, right? They gotta go together. So I'm gonna subtract. Nope, because I need to distribute it. I'll do it this way. Subtract. Alright, no, let's just do this. Okay, sorry. Alright, so subtract this whole thing over to the other side, right? So then you get x minus 2 plus 3i equals 0. Yeah? Now you're going to distribute because we get the same thing over there, so we'll just do it like this. I think it'll keep it easier. So then there you go. That's your factor there. Okay? All I did was I took that whole thing, moved it over to the other side because I had to subtract it. So x minus 2 plus 3i. So then I'm going to take this whole thing, and I need to move it over to the other side, so I'm going to subtract it, right? So then I get x minus 2 minus 3i equals 0, so that's mine. Okay? All right? And I realize some of you guys are looking at this and going, well, why didn't you distribute the negative? Well, then I could. If I distribute the negative, it's just this. If I distribute the negative here, it's just that. You know, you get the same thing, so I just wanted to keep it simple. We're just taking that whole thing and we're subtracting it over to the other side. Does that make sense? Okay. All right. So I'm gonna erase these equal zeros because those are the factors that I want to work with. We know it equals 0. All right. So I'm gonna take these two and I'm gonna multiply it. All right. This just gets so ugly. I know. All right. So we have. All right, guys. So you basically have 3 things in each of the parentheses, right? There's gonna be a lot of distributing going on. Okay. Make sure you keep yourself organized here. X. Distribute the X to everything.
Wait, did you put the no? The x is.
All right. X times X. X squared.
At least I tried.
X times negative 2. Negative 2x. X times 3i plus 3ix. Yeah? Are we okay with the first part? Okay. Go on to the second one. The negative 2.
Isn't that negative 3ix?
No, it's x times positive 3.
I'm doing it the other way around.
Okay, well then, if you do it the other way around, you can't ask me right now because I have, let me finish it this way first, okay? All right, so negative 2 times x is what? Negative 2x, okay? Negative 2 times negative 2. Positive 4. All right, now I'm going to make a new one over here. Positive 4. Negative 2 times 3i. Negative 6i. Okay. All right. okay? I know that looks weird, but it just makes it easier for me to combine everything later on. So you don't have to do it this way. You can write it all out, but I think this way is nice. It organizes it for you, okay? All right, so then the next one, last one. Distribute to everybody, yeah? Are we okay so far? Do you need a second?
3 times
Okay.
3 is 9, right?
All right.
Wait,
hold
is
on. All right. So now, negative 3 times x is negative 3. No, negative 3i times x is negative 3ix. Yeah. And you know what? I could put it in the next row, but there's an empty spot right there. Goes with it. I just put it in there. Negative 3i times negative 2 is 6i. Positive 6i. Negative 3i times 3i is negative 9i squared. Right? I know, so crazy. What? What's going on?
how is
Okay.
a negative times a positive? A
All right, so
negative
now
positive.
let's combine it.
Wait, this isn't making sense.
X squared. What's a negative 2x plus a negative 2x?
Negative 4x.
What happens to these 3ix's?
It's 0.
Uh-huh. And what about this 4?
That's
I'll bring
4.
that down. What happens
0.
to this 6i? Minus 9i squared, but what did we say about the I squared?
It's negative 1, so that becomes
Negative
9.
1.
It's 9.
So is x squared minus 4x plus 4 plus 9. What's 4 plus 9?
13.
That is your equation.
Can we go back up for a second?
Yeah, I'll go back up. Yeah.
Okay, so can you please explain to me?
Hold on. Did everyone write this down? Okay. All right. So